Hi, in this video we're going to find an unknown length when we've got one triangle inscribed inside another, so inside the other. Now, let's look at this diagram. We've got AC is 13, so I can put that on here. AC is 13 centimetres, and we need to find the length of AD, which is this length here, right? Okay, now we can use trigonometry to relate two side lengths and an angle in a right angled triangle. So we've got this right angled triangle here, but the trouble is we've got this side length of 32, but we don't know anything else. We don't know this side length, this side length, this side length. But if we look at the bigger triangle, this whole thing here, we've actually got an angle and a side length, and we could then work out another side length. Now, what side length should we work out in this big triangle? Well, can you see that the BC, the length BC, is common to both triangles? So that would seem like a sensible one to work out. So let's just give it a variable name, say x, because we don't know it. And I'm going to draw this out separately to help us. So we've got this triangle here, and we've got the x on the right, and we've got the 42, the angle of interest, and we've got the 13 as the hypotenuse. So how do we find the x? Remember, the first thing we do is we label the sides relative to this angle of interest. The angle of interest is just the labelled angle other than the right angle. And we're trying to relate it to these side lengths here that we're given. Now, this side here is the hypotenuse because it's the longest length of the triangle. So we label that as h. We previously saw how to do that. And then this side here is opposite that angle. We call it the opposite, so label it with O. And then we use our mnemonic, SOHCAHTOA, to work out which trigonometric ratio to use. Now, we're using O and H here. So the O and H is this one here. So this is the one we're going to use. And remember what that actually meant? We saw that meant sine of the angle of interest. We can call it theta. So I'm going to label this angle of interest with theta. It's just a Greek letter. And that is equal to the opposite divided by the hypotenuse. So you can see how this is just a shortened form of that. Now let's just substitute everything in. We've got sine of the angle theta, angle of interest, is equal to the opposite, which is the x, divided by the h, the hypotenuse, which is 13. Now I want to get x on its own. I don't like this divided by 13, so I'm going to multiply both sides by 13 to get rid of the divide by 13. So multiply both sides by 13. The left-hand side becomes 13 lots of sine 42. And the right-hand side, the times 13 cancel, divide by 13 to just give you x. So we've got x, we do 13 sine 42, which is equal to 8 point, I'm going to put lots of decimal places for the moment, 6987 will do. So I can now write out this x and replace it with 8.6987. Right, at this stage, we need to work out, what AD is. That is our ultimate goal. But we need to work out what this whole length is here. And we also need to work out this length of the smaller triangle. Now, to work out this whole length here, we could just use the big triangle again. We need to find out this whole length here. Now, we could use trigonometry again and use the fact that this is the adjacent. Or, because you already know two of the sides, you could use Pythagoras' theorem, because Pythagoras' theorem relates the three side lengths of this. So if I draw out my triangle again, and I put in the x, which I know, which is 8.6987, and the 13 here, and I want to find this length here, let's call it y. Now, remember how we label the sides of a right angled triangle? Well, the two shorter sides we label as A and B, and the hypotenuse, the longest length, we label as C. And then Pythagoras' theorem is A squared plus B squared is equal to C squared. So we substitute in, we get y squared plus the 8.6987 squared is equal to 13 squared. And then if we subtract the 8.6987 squared, and then we can square root both sides to get rid of the squared on the y. So I'm going to square root the whole thing. So that's why there's a missing 9 there, 6987 squared. So I'm going to do that on my calculator. The square root of 13 squared minus the previous answer I had squared and that is 9.66088. Right, so that's the y, which is this top length here. So this whole thing here is 9.66088, like that. Now we need to find AD, which is this yellow length. So we need to find this length as well. Now we can work that out using this smaller triangle here. So if I use the smaller triangle and just draw it out separately, we can see this is 8.69, what is it, 6987 on the right. And then we're trying to find the top length, dB, which we're going to just call, I know, Z. And then we've got the angle of 62 degrees here. So let's just use trigonometry again. We'll label the sides relative to this angle of interest. These are the sides of interest. Well, the 8.6987 is opposite the angle of interest, and the Z is adjacent to, next to. Now, if we look at our SOHCAHTOA, we're involving O and A. So O and A is here, so it's tan, isn't it? So we have tan of the angle of interest, 62, is the opposite, 8.6987, over the adjacent, which is Z. Now remember, if the variable is in the denominator, the quick way to deal with it is just to swap the thing you're dividing by and the result of the calculation. So these two things here. And if you do that, you get Z is equal to 8.6987 divided by tan 62. So let's do that. 8.6987 divided by tan 62. And that gives you Z is 4.6252. So, okay, that is the length of the top of this triangle here. So this is 4.6252. And now, can you see that we can just subtract this length from this length to leave AD, right? So I'll kind of run out of space at the bottom, so I'm just going to do at the top. I'm going to do that's AD, our length of interest, is the longer length, the whole length horizontally, 9.66088, and subtract the 4.6252. Let's do that. And that gives you 5.0357. And it wants it to one decimal place, so it's just 5.0 centimeters. And that is the final answer.